So actually I found this syllabus in the rest area. This is geosynthetics in tunnels. Okay, so I'm going to talk about how we use geosynthetics in tunneling. Okay. There are many things, but I will walk you through quite quickly so that I don't, so that you don't miss the lunch. Okay. So geosynthetics are used everywhere actually. So now tunnels becoming very long nowadays. 15 kilometers, 30 kilometers. In Korea, 3 years ago, we constructed 50 kilometers long tunnels. Okay. Not all the tunnels require geosynthetics, but some tunnels. Okay. I'm going to walk you through quickly. Okay. Geosynthetics are used in tunnels for waterproofing and drainage. Okay. But for the drainage purposes, we have to design. But sometimes design is not done. So that is a problem. Okay. So if the drainage is not properly designed, then you will see some kind of this kind of cracks within the tunnel, a lot of water coming in, and that eventually leads to structural failure. Okay? I think you all know the tunneling, but there are many different types of tunnels, cut and cover tunnel, TBM tunnels. I think in Melbourne Metro, you use a lot of TBMs, right? And drill and blasting, we call it conventional tunneling. In this tunnel, we have a lot of geosynthetics, okay, for waterproofing and drainage. Okay. So we call NATM, NATM. At the time, this tunneling method was introduced 1960s. New Austrian tunneling method, but nowadays it's not new anymore. Okay. And the construction is simple. We excavate, okay. We apply shotcrete to protect, and then reinforce with rock boards. Okay. So let me just show you the cycle. So sometimes we do the drilling or blasting. Okay, this is for the blasting. We install dynamite, and boom. Okay, we do the blasting. And remove we call muck, M-U-C-K. Okay, and then we apply shotcrete, which is the sprayed concrete. Okay, and then we do the rock bolting, reinforcement. Okay. And this is a cycle. Okay. But because ground itself have water, groundwater table, the tunnel is actually big a drain. Okay. So if tunneling is done under the groundwater table, then you have to provide some waterproofing as well as a drainage system. Okay. So this is a picture: excavation, shotcreting, and rock bolting. And then you provide waterproofing membrane, sometimes without drainage and sometimes with drainage, depending upon how the water is treated. And then you construct a final concrete lining. Okay. So you have a shotcrete layer and concrete structure. In between, you have waterproofing membrane and drainage. Okay. So this is final. Okay. So this is conventional tunneling. Okay. So conventional tunneling, the longest one is Gotthard-based tunnel in Switzerland, which is, I think that is 52 kilometers. Third one is Seikan tunnel in Japan. I think that is second, maybe 50.5, something like that. And third one is in Korea, which was constructed 3 years ago. That's 50.2 kilometers. Those are the conventional tunnels. Okay. So you do the math. How much geosynthetics are used for those tunnels? A lot of tunnels, the geosynthetics. Okay. So I think this is one of the busway and also tunnels which are being constructed by conventional tunneling. Now if in terms of utilage, there are hydraulic tunnels and also transportation tunnels. Geosynthetics, mainly geomembrane, are heavily used as a liner in hydraulic tunnels. Okay, so for the water convey. Okay. So let me just briefly talk about that. So here, the general concept: hydraulic tunnels are constructed to convey water. Okay. So initially, the tunnel has to be lined with steel or concrete. But as time goes by, the steel and concrete are deteriorated, and you have cracks and so on. Okay. So if crack happened, then water will be leaked from tunnel to ground, or from ground to tunnel, depending upon the hydraulic gradient. Okay. So you have to seal it using geomembrane. Okay. So if you use the geomembranes, the voids and cracks can be treated very easily. Okay. So geomembrane liner, we call it. The lining deterioration can be minimized by adapting geomembrane during and after the construction. Okay. So the geomembrane is very cost-effective and very efficient solution nowadays, okay, for hydraulic tunnels. PVC geomembranes are the main type of geomembranes that are being used in tunneling industry. This is the statistics came from International Tunneling Association. Okay. So what are the advantages of geomembrane? First, low permeability. Right? As you know, this is barrier. And high elongation. So geomembrane can bridge the old and new cracks. Very efficient. And because thickness is very thin, it doesn't compromise the tunnel diameter. If you have to use, the concrete structure, then has some, thickness, right? So that reduces cross-sectional waterway, which is not good. And also high chemical resistance and flexibility. And good weldability and easy installation. There are many, many good advantages of using geomembrane as liner in hydraulic tunnels. So very highly durable and reliable on the even on the high hydraulic pressure. Okay. And this is very good for rehabilitation work. Okay, as I mentioned, we can save time and cost, and it is very flexible and so on. Now let me show you the cross section. Okay. Let's suppose this concrete line is deteriorated. Okay. And what we do is, now this is deteriorated concrete lining. Okay. And first we have to put the drainage layer because of the crack, the water will come in anyway, right? If we do not provide drainage, then the water pressure will act on the tunnel lining. We don't want that. So we have to release the water pressure by providing drainage. Okay. And layer of geotextile and geomembrane. So this is a system. It's a lot of geosynthetics. Okay. If you don't want drainage layer, then you have to design this lining again to accommodate the hydraulic pressure. Okay? So this is very subtle. So by providing the drainage layer, you can release the water pressure acting on the tunnel. Okay? How about the transportation tunnels? Now you already saw. After we excavation, we spray the concrete and then apply rockboard, and then we provide waterproofing, geomembrane, and sometimes with the drainage layer, sometimes without drainage layer. Okay? Depending upon how you want to treat the water pressure. Okay? So the tunnel can be treated by the waterproofing, complete sealing, or drain. Okay? Either way. Okay? So we call this drain tunnel, undrained tunnel. Undrained tunnel means you don't want to provide drainage. Lining is designed to accommodate all the hydraulic pressure. We only need geomembrane. Okay? For drain tunnel, the lining tunnel, the concrete lining is not designed for the water pressure, but you have to provide drainage system. Okay? So either tunnel behaves differently. Okay? So we are talking about hydraulic aspect as well as mechanical aspect. Okay? But either way, geosynthetics are heavily used in tunnels. So as I mentioned, tunnel is a big, very big drainage system. Whenever you excavate the tunnel, you are destroying hydraulic equilibrium. So water will flow from high potential to low potential. Okay? So we have to define the way of controlling groundwater flow into the tunnel. Okay? So this is undrained proofing. Okay? If we provide geomembrane only, then the groundwater table will not be lowered. But on the tunnel, the concrete lining should be designed with this hydraulic pressure. So we call this undrained waterproofing. This is drained waterproofing. Because we apply geomembrane together with drainage system, you can lower the groundwater table. So in terms of the lining thickness, this is thicker, this is thinner. See? Structurally, the structural capacity of this lining has to be larger than this one. Okay? But in Singapore or Germany, sometimes the regulator doesn't want the groundwater table to be lowered. In that case, you have to adopt undrained waterproofing anyway in the city area, because groundwater drawdown means possibility of settlement. Okay? So we have to consider that as well. So this is drained waterproofing section. As you can see, this is shotcrete layer. And then you provide drainage system, a membrane, and concrete lining. So this drainage layer and plastic membrane are geosynthetics. Okay? But this drainage layer has to be designed with due consideration of filtration principle, geosynthetics. Okay? Let me explain to you why. Okay? This is undrained waterproofing. You only apply geomembrane. Okay? So this one, water pressure has to be considered. This one, you don't have to consider the water pressure for the tunnel lining. Okay? But this one requires a lot of maintenance, because the drainage layer, the system has to be maintained. Otherwise, it's gonna the water pipe is sometimes clogged, right? So you have to do a lot of maintenance. Okay. So these are the advantages and disadvantages of drain tunnel and undrained tunnel. For the drain tunnel advantage, you can reduce the thickness of concrete lining. Okay? But maintenance cost is quite high. For the undrained tunnel, you don't have to do maintenance, easy maintenance. But the structural capacity of lining should be maintained. That means thicker concrete lining means more excavation, you know. So there are advantages and also disadvantages for different type of tunnels. Okay. Okay. Now this is more detailed of drainage system for drained waterproofing. As you can see, this is shotcrete layer, and you have the we call geospacer, okay, drainage layer, and then geomembrane. Okay. And also we have longitudinal pipes. Those are have to be designed considering groundwater regime for your particular project site. We cannot just use geosynthetics off the shelf. Okay. There are many geosynthetic products available on the market for particular tunneling applications. All in one, you know. The geosynthetics, for example, geosynthetic geotextiles combined. The geotextiles is used for drainage and geomembrane, and this kind of composite type of geosynthetics are available on the market. Okay. What happens if the drainage system for drained waterproofing doesn't work? Well, immediately after construction, nobody cares, you know, because construction is done. Okay, but if drainage system fails over time, then you will see the consequences. Okay, that is structural problems. Okay, so this is intended design for drain tunnel. We are lowering groundwater table and very small hydraulic pressure. This is intended. So the concrete lining was designed without considering hydraulic head. This is after the clogging, failure of drainage system, then you will have water table going back to original, a lot of water pressure. Okay, so initially the concrete lining was designed without consideration of hydraulic pressure. Now a lot of water pressure is acting. That means structural failure. Okay. So this is concrete. You will have a lot of water pressure acting on the concrete lining. Then you will have structural failure of the concrete lining itself. Okay. Then what to do? We have to design the tunnel drainage system with due consideration of geosynthetic filter design. But this is not done. People try to just use the products off the shelf. That's it. Okay. So clogging and squeezing are two factors that deteriorate the drainage capacity of drainage system in the drained waterproofing system. Okay, the clogging, you know that the fine particles just block the opening. Okay, so the water cannot flow through. Okay, the squeezing. What is squeezing? Okay, let me just show you the squeezing. Okay, oops. Now, once you excavate the tunnel, the ground above the tunnel will act as a load to the concrete lining. So, as you can see here, the pressure due to the ground load pushes the concrete lining. But in between, we have geosynthetics, right? So because of the ground load, the thickness of the geosynthetics becomes smaller and smaller as time goes by. That means discharge capacity of drainage system becomes smaller and smaller. See? So there are two mechanisms, clogging and squeezing. They are two factors that deteriorate the drainage system of drained waterproofing system. Okay? So for the squeezing, we cannot do anything because that's a natural process. So what you have to do is you have to use thicker geosynthetics. The thicker, the better. Okay. However, for the clogging, we can design because already design principles are out there for the drainage system for the filter design. Okay. So there are the filter design criteria. We apply 3 different principles: retention criteria, permeability criteria, anti-clogging criteria. Okay. There are already fixed design criteria available, okay, that you can follow. So there are many different type of design criteria, but simply we compare the opening size of the geosynthetics and particle size of the soil. That's it. Okay. You can go through later. I'm leaving my slide here. You can go through later. Okay. Then what happens if we do not? Now, by the way, this is the Korean Seoul Metro. We are now operating 9 different lines. How about the length? Seoul Metro alone. Any guess? Huh? Oh. 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 Bingo. 400 kilometers long. So, well, Seoul is very populated city, but we have very good public transportation system for the subways and bus system. We have bus only lanes. So if you have any appointment, you have to keep the time. You don't want to take a taxi, either bus or subways. Now subways are all connected. You have very nice, very clean, and all the stations are equipped with screen doors. Why? Automatic screen doors, because people jump into the lane when train comes. There have been very, very big problems. Okay? So the the Seoul government decided to install all the screen doors in every stations. That costs a lot of money, but anyway. So whenever you come to Seoul, I think the Seoul Metro is the one thing that you have to experience. Okay. So what happens to? Let me just jump over to what happens if we have deteriorated drainage system. Okay. Okay. So this is analysis. So this is the drained waterproofing system when it works well. Okay. Hydraulic pressure on the tunnel is almost 0. As the drainage system deteriorates, you can see that water pressure build up behind the tunnel lining. Okay. So this is completely clogged. Okay. So when you design for tunnel lining without hydraulic pressure, let's say that is 30 centimeter thick. Okay. If you have this situation, then your lining will be cracked. So the lining thrust increases as the drainage system deteriorates, and bending moment increases, and then finally you will have these cracks. So you don't want that to happen, right? So for the drained waterproofing system, at least we need some design guidance. We can adapt filtration design principles. So we take the soil sample, you check whether just textiles that you are trying to use is appropriate for that particular soil. That can be done easily. Okay? So this is what I am trying to educate Korean tunnel designers. They know what the geosynthetics are, but they don't know the principles. Okay? So I'd like to be a messenger for how we design the geosynthetics for tunnel use. Okay? Conclusion speaks for itself, so thank you for your attention.